China has begun testing a cutting-edge sixth-generation fighter jet codenamed Beiding, or White Emperor.
In the high-stakes arena of global aerospace innovation, a new race for aerial supremacy is unfolding, with China emerging as a formidable contender. While the United States and Russia have long dominated the skies with their cutting-edge aviation technology, China's meteoric rise in this domain is reshaping the balance of power. Beijing's relentless pursuit of aerial dominance reflects not only its technological prowess, but also its strategic ambition to redefine the rules of modern warfare. This battle for supremacy in the skies is no longer a contest of engineering brilliance alone. It is now a geopolitical chess game. And the Dragon has played a move, a pretty big one too. China's first sixth-generation fighter jet has shocked the United States. But how big of a deal is this really? Well, let's find out, and we'll also take a deeper look at the Sino-American competition for aerial supremacy, China's sixth-generation aerospace fighter jet. This is no rumor. It is not secret intel. It is not even a claim. This is as real as the world around us. Newly surfaced footage has revealed the maiden flight of China's sixth-generation stealth fighter jet for all to see. Captured in broad daylight over Sichuan province, the jet's sleek, tailless, triangular design marks a radical departure from the conventional forms of its fifth-generation predecessor, the J-20. This next-generation aircraft, unofficially dubbed the White Emperor, exhibits advanced stealth features, including the elimination of vertical tail fins to reduce radar cross-section and enhance directional stability through wingtip control surfaces. The prototype was seen flying alongside a J-20, providing a visual contrast that highlights its evolutionary leap in aerodynamics and stealth engineering. This latest revelation is part of China's long-term plan for military innovation. The country's unveiling of the J-35A stealth fighter at the Zhuhai Air Show showcased its ambitious response to Western benchmarks like the F-35, which is considered the best aerial supremacy fighter in the world, and an icon of the United States' capacity for innovation. Now, with the emergence of a sixth-generation contender, Beijing is signaling its intent to redefine the balance of air power. Alongside advancements in hypersonic flight, artificial intelligence, and space exploration, China's military modernization has profound implications for global strategic stability. If this mysterious aircraft represents the next phase of its aerial warfare capabilities, it not only challenges the dominance of the United States and its allies, but also accelerates a technological arms race that is reshaping the geopolitical landscape. The White Emperor is a product of the Aviation Industry Corporation of China, or AVIC, a state-owned enterprise at the forefront of the nation's aerospace innovation. This sixth-generation aircraft can reach supersonic speeds that challenge existing performance benchmarks. Perhaps most strikingly, it can momentarily exit Earth's atmosphere, signaling a foray into aerospace capabilities. This capability potentially allows for orbital reconnaissance or evasion maneuvers that render it nearly untouchable by contemporary defense systems. Its modular fuselage design takes versatility to a new level, enabling quick reconfiguration for diverse combat scenarios, from air superiority missions to deep strike capabilities. This modularity could theoretically extend to incorporating advanced payloads, such as hypersonic weapons, or even adapting the craft for unmanned operations. Another standout feature is its expanded internal missile bays, a strategic choice aimed at maximizing stealth. By housing weaponry internally, the White Emperor reduces its radar signature significantly, while also accommodating a larger payload. This aligns with China's broader strategy to develop aircraft that combines stealth with high lethality. These innovations make the White Emperor uniquely suited to bypass advanced detection systems like the AN/SPI-6 radar used by the United States or Israel's Iron Dome. The design innovations of the White Emperor emphasize stealth and aerodynamics. Its angular surfaces are optimized to scatter radar waves, making it nearly invisible to modern detection systems. The absence of vertical tail fins is another innovation. This was a hallmark of earlier generations like the J-20, however. By doing away with it, engineers have paved the way for adaptive wingtip control surfaces instead. This has resulted in enhanced maneuverability while preserving the aircraft's stealth profile. This reflects lessons learned from both Chinese and foreign designs, merging these into an aircraft poised to outclass its contemporaries. The White Emperor's development is deeply tied to China's focus on integrating advanced technologies into military applications. This initiative involves collaborations between military and civilian sectors, including the application of artificial intelligence, quantum computing, and new materials science to aerospace projects. The program's success underscores China's broader strategy of achieving civil-military fusion to leapfrog technological barriers. The strategic implications of the White Emperor's development are profound. Its multifaceted capabilities position China as a formidable player in the race for aerospace dominance. Beyond direct military applications, this fighter could play a role in shaping geopolitical dynamics. Its hypersonic and orbital features challenge existing missile defense systems, potentially rendering them obsolete. Furthermore, the White Emperor symbolizes China's ability to innovate independently of Western technological paradigms. But that's not all. China is rapidly advancing in other areas of avionics as well. China's latest unmanned cargo aircraft VT-30 is another major leap forward in both China's aerospace technology and its ambitions in autonomous systems. Developed and tested by Sichuan Tangan Technology, the prototype for VT-30 underwent its successful test flight at Fangming Airport, located in Sichuan Province. The unmanned cargo aircraft is designed with high automation, making it capable of operating with minimal human intervention. This allows for seamless, real-time adjustments during flight, from course corrections to weather-related evasions, all executed with precision. With its advanced safety features, including automated collision avoidance systems and emergency landing protocols, the aircraft can operate in challenging and hazardous conditions that would otherwise risk human life. The vehicle is intended for remote regions, where access to conventional transport infrastructure is limited. The system is robust enough to guarantee safe and efficient delivery, even in adverse weather, strong winds, or mountainous terrain. In terms of payload capacity, VT-30 can carry up to 2 metric tons, making it highly suited for medium-weight cargo transport. This capacity makes it ideal for delivering supplies to locations that would otherwise require human-operated aircraft, such as in the mountainous regions of Tibet, rural farming areas, or offshore islands. Its size and weight allowance also open up possibilities for transporting critical supplies, such as medical equipment, food, or industrial parts to regions where traditional logistics infrastructure is lacking or too costly to maintain. The aircraft will essentially bridge the logistical gaps that exist in remote and inaccessible areas. Many regions in China, particularly those in the western and southwestern provinces, are characterized by rugged terrain, lack of roads, and difficult weather conditions that make conventional truck or ground-based transport unfeasible. Here, unmanned cargo aircraft can play a transformative role by quickly delivering essential goods. Of course, the military applications are also virtually limitless, especially in the scenario of a Taiwan Strait conflict where logistics will make all the difference. But how did China get to this point? Was it not an impoverished country struggling to survive when the United States was spending satellites in space? Well, this brings us to the shady but effective origins of Chinese military technology. Stealing tech from the United States and other established power. The Soviet Union and the United States both played pivotal roles in pushing China toward rapid defense modernization, albeit through aggressive tactics and intimidating stances. The former initially provided support to the Chinese military after the establishment of the People's Republic in 1949, but tensions soon arose, primarily over ideological differences and territorial disputes. By the late 1950s and early 60s, the relationship soured dramatically, culminating in the Sino-Soviet split. The USSR withdrew its technical assistance and military support, leaving China vulnerable in the face of a hostile world. At the same time, the United States, under the leadership of President Dwight D. Eisenhower, was deeply entrenched in the Cold War, and its policies toward China were aggressive. The United States repeatedly threatened China with military action, including nuclear retaliation, over issues like Taiwan. This may not seem like a big deal now, but back then the United States had already used nuclear weapons on Japan only a few years earlier and was more than okay with using it against China. This brutal external pressure from both superpowers propelled China to aggressively modernize its defense sector. In the wake of Soviet betrayal and US threats, China turned to alternative means of strengthening its capabilities. Espionage, covert operations, and the importation of scientific knowledge and technology from the West and other regions became key strategies. China began to aggressively pursue indigenous defense innovation. By the late 20th century, China had mastered methods of reverse engineering foreign technology, often pilfering vital defense secrets, which would later help fuel their military-industrial complex. The pursuit of this technological knowledge, whether through overt or covert means, laid the foundation for China's rise as a major global military power. In the early 2000s, and continuing through the 2010s, there were significant efforts by Chinese intelligence to acquire sensitive US military technologies. One of the most notorious cases involved Glenn Duffy Shriver, an American man who was recruited by Chinese agents to pass on classified US military technology related to satellites and other sensitive defense information to the Chinese government. This included technology that was critical to advanced military systems, including aircraft like the C-17 Globemaster III. This dual-usage cargo aircraft was crucial for the United States military due to its large cargo capacity, long range, and ability to operate from austere airfields, making it essential for rapid troop and equipment deployment. China needed access to this technology to enhance its own airlift capabilities, enabling faster and more flexible military logistics, especially for strategic operations in the South China Sea and beyond. Chinese agents, through contractors or through personal connections, sought information on the design and performance capabilities of C-17, which could greatly enhance China's own airlift and military mobility operations. It was discovered that a Chinese spy ring had attempted to steal valuable aerospace data from major US defense companies like Boeing, which was heavily involved in the development of the C-17. These individuals, some of whom were contractors, often worked under the radar, leveraging their access to gather information and pass it along to Chinese handlers. Shriver's case was a clear example of how China used both contractors and spies to infiltrate the US defense industry. Shriver, while not directly connected to the C-17, was accused of attempting to facilitate the transfer of critical technologies. He was arrested in 2010 in Canada after US authorities intercepted an email detailing his attempts to recruit others to acquire classified information for Chinese officials. The espionage ring, including contractors like Shriver, played a role in gaining access to US military information. China unveiled its replica of the C-17 Globemaster III, known as the Y-20, in 2013, shocking the world with its striking resemblance to the American cargo aircraft. This move highlighted China's growing aerospace capabilities, showing that it had successfully replicated key aspects of US technology. But that's not even the smartest bit. While the United States spent billions on years of research and development for the C-17, China managed to create its version in a fraction of the time and at a much lower cost. This leap in technology allowed China to bolster its military logistics capabilities, bringing it much closer to competing with the United States in terms of global airlift power. Another example is China's J-31 stealth fighter. This fifth-generation stealth fighter and aerial supremacy aircraft is essentially China's F-35 clone. The J-31 was heavily influenced by the design features and technologies of the F-22 and F-35 stealth fighters, both of which are among the most advanced aircraft in the world. It has been widely suspected that Chinese spies managed to steal crucial information from Lockheed Martin's F-35 program and Northrop Grumman's F-22 project. Some reports even suggest that Chinese engineers were able to reverse engineer specific design elements of the F-22, especially its stealth technology and low observable coatings, by exploiting vulnerabilities in the US security system. The iconic J-31 made its first flight in 2012 and is now being actively promoted as China's counter to Western fighter jets like the F-35 and the F-22. It is equipped with advanced avionics, stealth capabilities, and a powerful radar system, all of which were influenced by Western technology, but also adapted to meet China's strategic needs. With this impressive addition to its military hardware lineup, China has been able to compete on a more equal footing with the United States and its allies, reshaping the global balance of air superiority. Furthermore, the J-31 has played a significant role in China's broader military modernization agenda, as it is designed to fulfill a wide range of roles, including air superiority, strike missions, and even aircraft carrier operations. This makes it a versatile asset for the Dragon. This recent leap forward is a huge deal, considering that in the 1980s and early 90s, China's military aircraft and aerospace capabilities were rudimentary compared to the United States. The People's Liberation Air Force relied on Soviet-era designs like the MiG-21 and Su-27 as their primary airframes. While these aircraft were relatively effective, they lacked the cutting-edge technology and aerial dominance that the United States had built through decades of innovation. By contrast, the United States had already developed and deployed revolutionary technologies like stealth aircraft, such as the F-117 Nighthawk, F-22 Raptor, and F-35 Lightning II, and sophisticated electronic warfare systems, which China lacked. In fact, it wasn't until the mid-2000s that China began to close the gap, thanks in large part to the theft of US technology. Today, China's aerospace and defense industries are not only self-sufficient in many areas, but are also pushing the envelope on advanced technologies, such as hypersonic missiles and AI-powered autonomous systems. Moreover, unlike the Soviet Union, which faced a technological blockade from the United States throughout much of the 20th century, China has been far more successful at integrating stolen technologies into domestic production. This has allowed China to not only catch up to the United States in many areas, but also become a formidable competitor in aerospace and defense technology. Looking forward, China is likely to continue its efforts to acquire cutting-edge technologies through cyber espionage, intellectual property theft, and reverse engineering. However, China's focus is shifting toward indigenous innovation as well, with an increasing emphasis on developing next-generation technologies that are not reliant on foreign sources. The rapid development of China's own sixth-generation fighter jets, hypersonic weapons, and unmanned aerial vehicles demonstrates this shift in focus. So, how is the United States responding to all of this? Boeing Phantom Eye UAV. Developed under the Advanced Development Programs division of Boeing, also known as Phantom Works, the Boeing Phantom Eye is a high-altitude UAV capable of reaching altitudes of 19,826 meters, or 65,000 feet, far exceeding the operational ceilings of most conventional UAVs. This extraordinary ceiling places the Phantom Eye in the stratosphere, where it can stay out of reach from most surface-based threats, including conventional air defense systems. The UAV's design, optimized for long-duration flights, ensures its capability to operate for up to 4 days without needing to land, making it highly suitable for persistent reconnaissance missions, border surveillance, and communications relays. At the heart of the Phantom Eye's design is its hydrogen-fueled internal combustion engine, which allows it to achieve remarkable endurance compared to conventional fuel-based UAVs. These engines provide both the fuel efficiency and environmental benefits that have made the Phantom Eye a groundbreaking technology in the field of aerospace engineering. In terms of payload, the Phantom Eye is equipped to carry up to 204 kilograms, or 450 pounds of equipment. This payload capacity is ideal for reconnaissance, surveillance, and communication equipment such as high-resolution cameras, radar systems, and signal intelligence sensors. The UAV's large wingspan, which measures almost 46 meters or 151 feet, and sleek, aerodynamic design enable it to carry such a payload while maintaining optimal lift and fuel efficiency at extreme altitudes. The Phantom Eye's long-term operational capabilities, enabled by its hydrogen fuel, allow it to stay in the air for days or weeks without requiring frequent fuel resupply, unlike traditional aircraft that would require regular fuel stops. Phantom Eye's design also incorporates lightweight composite materials, minimizing the weight and further contributing to energy efficiency. Moreover, its long-range communication systems and satellite connectivity ensure that data from the UAV can be transmitted back to the control station without needing to land for servicing, thus maintaining a seamless operational capability. U.S. supersonic passenger aircraft projects. The development of supersonic passenger aircraft in the United States has garnered significant attention in recent years, with various cutting-edge projects designed to push the boundaries of aviation technology. One of the most daring and technologically advanced projects in the realm of supersonic flight is Hermeus's Quarterhorse, a development funded by the United States Air Force to explore the future of hypersonic passenger transport. The Quarterhorse is designed to reach supersonic speeds of up to 6,125 kilometers per hour, or Mach 5, putting it in the category of hypersonic flight, which is 5 times the speed of sound. Unlike traditional supersonic aircraft, which focus on transonic flight around Mach 1 to Mach 2 speeds, the Quarterhorse seeks to break the sound barrier by an order of magnitude, reducing flight time for intercontinental travel from hours to mere minutes. In terms of funding, the United States Air Force allocated a remarkable $60 million for the testing phase of Quarterhorse, demonstrating the significant interest and investment in developing technologies that could propel the United States back to the forefront of supersonic passenger aircraft. The Quarterhorse aims to prove that not only is hypersonic flight possible, but it can also be achieved with a civilian transport model. The project's technology will also lay the groundwork for military applications, such as high-speed reconnaissance or cargo transport, providing dual-use capabilities. The Quarterhorse is designed with advanced airframe and propulsion systems to withstand the extreme temperatures and pressures associated with hypersonic speeds. Its scramjet engines, in particular, are integral to achieving and maintaining the hypersonic velocities required for global travel, and its airframe is designed to handle high-speed aerodynamics while minimizing drag and maximizing efficiency. If successful, Hermes's Quarterhorse could reduce trans-Pacific flights to under 2 hours. Lockheed Martin's X-59 QSST, which is short for Quiet Supersonic Transport, is another option in this arena. But this one is focused on achieving supersonic speeds at a more modest Mach 1.4, which is approximately 1,700 kilometers per hour. While this is far slower than the Quarterhorse, it's still a significant leap over traditional subsonic aircraft, and what sets the X-59 QSST apart is its primary goal, which is to address one of the most significant challenges in commercial supersonic flight: sonic booms. The sonic boom has long been one of the main reasons commercial supersonic flights, like the Concorde, were banned over land in many countries. The X-59 features a sleek, long fuselage and an advanced nose shape that stretches out to reduce the pressure waves produced by the aircraft as it breaks the sound barrier. This design will allow the X-59 to produce a sound more like a gentle thump or a quiet pop, as opposed to the loud, disruptive sonic boom. The X-59 project has been funded as part of NASA's Low Boom Flight Demonstrator program to prove that supersonic air travel can be both viable and acceptable for commercial use, even over populated landmasses. This technology could open the door to the return of supersonic flights for passenger airliners, potentially leading to a new era in global air travel. With Lockheed Martin's expertise in advanced aerodynamics and low-boom technologies, the X-59 is expected to complete extensive flight testing in the coming years. Of course, the technology that goes into making the Hermes Quarterhorse and NASA's X-59 QSST a reality will also have serious military applications, especially in the arena of logistics and troop transport. Additionally, the successful implementation of supersonic commercial travel could significantly improve the global economy by increasing the speed of business and diplomatic exchanges. With greater emphasis on speed, people could spend more time at their destinations, enhancing productivity and enabling more efficient global communication. Together, these projects highlight the United States' continued leadership in aerospace innovation and its determination to reclaim its position as a global leader in supersonic transport. The impact of these developments could be transformative, offering faster, more efficient, and environmentally conscious air travel in the future. How does aerial supremacy work in the favor of the United States? Aerial supremacy has long been a cornerstone of US military strategy, providing the ability to dominate both the skies and broader domains of warfare. Throughout history, the US has effectively leveraged its air superiority to ensure strategic dominance on the battlefield, often influencing the outcome of conflicts. One of the most prominent historical examples of aerial supremacy in US military history is during the Second World War. The United States' use of long-range bombers like the B-17 Flying Fortress and the B-29 Super Fortress, coupled with fighter aircraft such as the P-51 Mustang, played a pivotal role in dismantling the Axis powers' infrastructure. The Battle of Midway in 1942 exemplifies the role of air power, where US aircraft carriers launched devastating airstrikes that sank 4 Japanese carriers. In the modern era, aerial supremacy continues to be a decisive factor, as seen in the Gulf War. The United States led a coalition that swiftly gained control of the airspace over Iraq, using precision-guided munitions, stealth bombers like the B-2 Spirit, and advanced fighter jets such as the F-117 Nighthawk. The shock and awe campaign disrupted Iraq's command and control systems, crippled its military infrastructure, and significantly weakened its ability to defend against ground operations. The quick and overwhelming use of air power in the Gulf War demonstrated how controlling the skies could ensure victories on the ground. In more recent conflicts, such as the wars in Afghanistan and Iraq, US air superiority allowed for real-time surveillance, precise airstrikes, and rapid troop deployment, fundamentally changing how warfare was fought. The ability to use drones like the MQ-9 Reaper for targeted strikes and intelligence gathering has reshaped modern combat, making the US military a formidable force in asymmetrical warfare. The ability to observe and strike with precision from the air has enabled the US to minimize ground troop exposure and inflict crippling blows to adversaries, even in challenging environments. Furthermore, the US military's dominance in space, including satellite communication, reconnaissance, and GPS guidance, is a direct extension of its aerial supremacy. Satellites provide the United States with real-time data that aids both air and ground operations, reinforcing the concept of a multi-domain approach to warfare, where air power and technological integration ensure battlefield success. In addition, the US has maintained its advantage by developing cutting-edge technologies, such as the F-22 Raptor and the F-35 Lightning II, which are capable of stealth, advanced avionics, and superior maneuverability. These aircraft not only dominate the airspace, but also provide support for ground forces, ensuring that US operations can be conducted with unmatched efficiency. The integration of artificial intelligence and UAVs further strengthens the US's grip on air superiority, allowing for autonomous operations and extended missions. How will China's newfound aerial supremacy factor in a future Taiwan conflict? For decades, Taiwan's security has been deeply reliant on the United States, which has provided critical military support, including advanced fighter jets like the F-16s, air defense systems like the Patriots, and naval assets to ensure Taiwan's defense. However, as China continues to advance its military technologies, including its new 6th-generation fighter jet, the White Emperor, drone swarm tactics, and sophisticated anti-ship missiles, Taiwan's reliance on the US may not be enough to counter the People's Liberation Army. The resolve behind China's ambition to reunify Taiwan is rooted in a century of humiliation, where the country was subjected to foreign domination, territorial losses, and internal strife. Taiwan, as a breakaway province, has been viewed by Beijing as an integral part of China's territorial integrity. This historical context shapes China's aggressive stance toward Taiwan. This resolve is amplified by the failures of foreign powers, particularly during the Opium Wars, when China was forced to cede territories to foreign powers, and the later rise of the CCP, which has been keen on demonstrating its strength by reclaiming lost territories like Taiwan. In any potential Taiwan conflict, aerial supremacy will be one of China's most decisive advantages. Historically, air superiority has proven to be a decisive factor in warfare, as evidenced by events like the Falklands War of 1982, where British Harrier jets provided a clear edge over Argentine forces. In modern warfare, air dominance allows a nation to control not only the skies, but also to shape outcomes on the ground and at sea. China's growing fleet of advanced fighter jets, including its upcoming 6th-generation stealth fighters, is designed to give the PLA overwhelming superiority in any aerial confrontation. China is also investing heavily in unmanned systems, particularly drone swarms, which will be crucial in a Taiwan conflict. Similar to the tactics employed by the Houthi rebels in Yemen, who used drone swarms to strike high-value targets such as Saudi oil facilities, China plans to deploy vast numbers of drones in a variety of roles, from reconnaissance to strikes on enemy air defense systems, naval vessels, and critical infrastructure. These swarms would overwhelm Taiwan's air defense systems and significantly disrupt its ability to retaliate or defend against more sophisticated threats. The use of drones also allows China to field a much larger, cheaper, and more expendable force that can carry out missions across a wider range of targets. China's anti-ship missile capabilities, particularly the DF-21D carrier killer, are another significant aspect of its aerial and naval strategy. These missiles, capable of striking US aircraft carriers and other naval assets from great distances, will provide China with the ability to neutralize Taiwan's maritime defenses. In the event of a conflict, China could launch these missiles from land-based platforms, severely restricting the freedom of movement of US and Taiwanese naval forces. This tactic, which mirrors the Houthi strategy of launching land-based attacks against maritime targets, could force the US Navy to keep its distance, diminishing Taiwan's ability to counter Chinese actions in the air and at sea. Lastly, China's new 6th-generation fighter will play a pivotal role in any potential confrontation over Taiwan. Using stealth technology, advanced sensors, and hypersonic weapons, the White Emperor will not only penetrate Taiwan's airspace with minimal detection, but also target critical infrastructure with pinpoint accuracy. The significance of this new 6th-generation fighter extends beyond Taiwan. It is one component of a much broader strategy that aims to establish China as a global military power. Along with its missile capabilities, drone swarms, and cyber warfare initiatives, this fighter will enable China to conduct multi-domain operations. The combination of advanced aerial warfare capabilities, superior intelligence, and cyber operations will allow China to disrupt, isolate, and defeat adversaries in a way that was previously not possible. This multifaceted approach gives China a serious edge over Taiwan's outdated defense systems, which depend heavily on the United States. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.